Dr. A. Anita, Assistant Professor of Chemistry from V.V. Vanniyaperumal College for Women, Virudhunagar. In this module, I will deal with the osmotic pressure. In the previous videos, you can see what are colligative properties and the different colligative properties like lowering of vapor pressure, elevation of boiling point and depression of freezing point. Following that, in this module, I will deal with the fourth colligative property, that is osmotic pressure. Before getting into the osmotic pressure, we have to know what is osmosis and what's its relationship between the diffusion and osmosis. Here we are taking the concentrated solution and over it we are taking the pure solvent. Pure solvent is nothing but the absence of the solute, whereas the concentrated solution indicates that is more amount of solute is present in the given amount of the solvent. Consider we are having concentrated potassium permanganate solution as the concentrated solution and pure solvent, that is simply water over it. After some time we are finding out the concentration of both the layers become equal to each other. That is, in the potassium permanganate solution, potassium permanganate is the solute and water is the solvent. This both the potassium permanganate as well as the water moves over both the layers and until it reaches the equal concentration. That is called as diffusion. But when coming to osmosis, when there are difference in their concentration or when there are the separation between the concentrated solution as well as the pure solvent, if it is separated by a semi-permeable membrane. Permeable means if it allows to pass through it, then that membrane is called as a permeable membrane. If it allows one of the component to pass into it, then that membrane is called as the semi-permeable membrane. That semi-permeable membrane allows only the solvent molecules to move over it or move through it, whereas it does not allow the solute particles to get into it. That is the function of the semi-permeable membrane. Now the concentrated solution and the pure solvent are separated by a semi-permeable membrane. Here only the solvent molecules can move. Therefore, the concentration of the solvent is more in the pure solvent, whereas it is less in the concentrated solution side. Therefore, the solvent moves from its higher concentration side to its lower concentration side until both the concentrations become equal to each other. In this case, the potassium permanganate does not allow to move from the lower phase to the upper phase. This is called as the osmosis. That is, osmosis is nothing but the flow of solvent through a semi-permeable membrane from a pure solvent region to the concentrated solution region is called as osmosis. And this is indicated in this figure when the dilute solution and concentrated solution are separated by a semi-permeable membrane placed vertically. The solvent molecules are allowed to move from the dilute solution to the concentrated solution, as well as the solvent molecules also moves from the concentrated solution to the dilute solution. That is, the semi-permeable membrane allows only the solvent molecules to move through it. Therefore, after some time, as more amount of solvent molecules are moving from the dilute solution to the concentrated solution, the level of solvent molecules or the level of solution rises, and therefore there will be increase in the solution level in this left hand side, that is the concentrated solution side. That is due to the osmosis. Next we will see about what is osmotic pressure. In this diagram, in order to create a semi-permeable membrane, we are taking the cupric ferrocyanide membrane deposited on the porous wall is acting as a semi-permeable membrane. In that we are taking the concentrated solution inside the porous part and it is separated by a semi-permeable membrane. In that beaker we are having the pure solvent, that is the water. Now here the osmosis can be taking place. As the water molecules enters through the semi-permeable membrane, there will be a rise in the water level in this tube attached to it. From the initial level, the water level rises to the maximum level. After particular amount of time, the level of water remains stable, that won't increase further. As a result of increase in the volume of water in this small narrow tube attached to it, there will be an increase in the pressure due to water, that is called as the hydrostatic pressure. This hydrostatic pressure exerted by the excess solvent in this tube hinders the osmosis of water into the semi-permeable membrane. This hydrostatic pressure prevents the water to allow into the semi-permeable membrane. As a result, osmosis tends to stop. Therefore, thereafter the osmosis haven't taken place. Similarly, if you are taking the same setup in this case, the hydrostatic pressure can be also taken as the external pressure. If we are applying external pressure, then the osmosis can be stopped. When we apply the hydrostatic external pressure equal to the hydrostatic pressure, then the solvent molecules cannot semi-permeate into the solution side. That is called as the osmotic pressure. What's the hydrostatic pressure developed by the water in this is called as the osmotic pressure, or otherwise it is called as, in order to avoid or prevent the osmosis to take place, we are applying certain amount of pressure externally in the solution side in order to prevent the osmosis is called as the osmotic pressure. That is given as the osmotic pressure may be defined as the external pressure applied to the solution phase in order to prevent the osmosis of solvent into the solution phase separated by a semi-permeable membrane. Now, we can see how this osmotic pressure can be measured. Though there are many methods to determine the osmotic pressure nowadays, initially they are determined by Pfeffer method and then Berkeley-Hartley methods, and later on it can be measured by a modern osmometer, which with the improved facilities. Now we can see the description of this modern osmometer. Here it is a stainless steel container. All this container are made up of stainless steel with two compartments. One is for the solvent, the another is for the solution. Here it is the inlet tap for the solvent as well as for the solution, and they are separated by a semi-permeable membrane. In the compartment of the solvent phase, there is a diaphragm. This diaphragm is a flexible one, whereas the semi-permeable membrane is fixed permanently. Therefore, it cannot move up or down. Whereas this diaphragm is a flexible one, depending upon the amount of solvent present in this compartment, it can be moved its shape and changes its size. Initially, we are taking this apparatus, and through this inlet, we are filling this compartment with solvent. And through this inlet, we are filling this compartment with the solution and then tightly closed. Now, the solvent phase and the solution phase are separated by a semi-permeable membrane. Now, the diaphragm is rigid. That is, it won't be loosened. As after some time, the osmosis begins to take place. Osmosis is nothing but the movement of solvent through the semi-permeable membrane to the solution side until a particular hydrostatic pressure exerts. As more of the solvent molecules move into this phase, there will be a decrease in the amount of the solvent in this compartment. As a result, the diaphragm begins to distort. Distort means it gets loosened. Therefore, the extent of distortion of diaphragm is directly related to the osmotic pressure. That will directly indicates how much of solvent is moving through it and what is the hydrostatic pressure acquired, and that much hydrostatic pressure is decreased in this layer. That will lead to the distortion in the diaphragm. This distortion in the diaphragm is measured using a strain gauge that will reads how much the diaphragm is distorted. This strain gauge is attached to the electrical output in order to give the osmotic pressure directly. This is the working of the modern osmometer. We are simply filling that with the corresponding solvent and the solution. After maintaining, keeping it for some time, we can find out the osmotic pressure digitally through this modern osmometer. And this is the working of the modern osmometer. Next, we will see what is the application of the osmosis. Osmosis plays a very important role nowadays, which are commonly called as RO plants, that is reverse osmosis plant. Whenever we are in need of pure drinking water, potable drinking water, we are making use of the reverse osmosis method in our domestic life in order to bring the potable drinking water from any source of underground water. In the normal osmosis, the movement of solvent is taking place from the solvency phase to the solution phase, and thereby the water level increases and there the hydrostatic pressure exerts, that is known as the osmotic pressure. The osmotic pressure prevents the movement of the solvent into the solution compartment, that is it prevents the osmosis to take place. If we want to prevent the osmosis, we have to apply the external pressure equal to that of the hydrostatic pressure. If we want to make the osmosis to happen in a reverse manner, we have to apply an external pressure which is greater than that of the osmotic pressure, then the reverse of osmosis can take place. That is called as the reverse osmosis. Therefore, reverse osmosis is nothing but the movement of solvent from the solution phase to the pure solvent phase on application of the external pressure greater than the normal osmotic pressure. That is called as the reverse osmosis. Through the reverse osmosis method alone, we can desalinate the seawater into potable water. That is, the desalination of seawater is an application of the reverse osmosis. The osmosis forms the basis of this method. Therefore, the seawater is allowed to pass into this hollow tube with a semi-permeable membrane inside it. The semi-permeable membrane is a hollow fiber. Here we are passing the seawater through under pressure. That pressure should be higher than that of the osmotic pressure. When the water flows into it, this membrane under pressure, the membrane allows the solvent molecules from the solution phase through this membrane into this tube, which will get through this the desalinated water can be passed to it. Here in this case, the desalination water is here. From the desalination water all the water moves through it and we are getting the fresh water when we apply the pressure greater than the osmotic pressure. Therefore, from this the seawater is converted into a drinking water through the reverse osmosis membrane. Here this membrane plays an important role. That is, the semi-permeable membrane prevents the osmosis to take place in a manner and the reverse osmosis have to take in place. Therefore, we are getting the desalinated water from the seawater. This is the application of the reverse osmosis, and through this osmosis we are able to get the desalinated water or the potable water from whatever the source of water is. And that's all about the reverse osmosis and its application of the desalinated water. Thank you.